Let us discuss carbonyl compounds. In the carbonyl compounds, we have discussed aldehyde and ketone. Now we will go for carboxylic acids. First, we will see preparation of carboxylic acids. We will see. So, in the preparation of carboxylic acids, one is oxidation of alcohols gives carboxylic acid. Oxidation of alcohols gives carboxylic acid. Then cyanides undergo hydrolysis to give carboxylic acid. Next, using Grignard reagent, how to get carboxylic acid, that we'll see. Okay, using Grignard reagent, how to get carboxylic acid, that we are seeing. Now we will take the Grignard reagent, suppose CH3 MgBr. We have taken the Grignard reagent like this. Okay, this Grignard reagent is treated with what, in the sense carbon dioxide in the presence of dry ether. In the presence of dry ether, what is a product obtained, so that we'll see. Okay, so now carbon dioxide we can write like this. We are writing carbon dioxide like this. Grignard reagent we will write like this. Grignard reagent. Now how the reaction takes place, that we'll see. See this bond shifting to this carbon attacking this carbon, this bond shifting to this oxygen attacking this magnesium. Okay, so why this carbon is attacking this carbon? This carbon is having positive charge, this carbon is having negative charge. Therefore, negative charge is attacking this positive charge. Okay, so what we will get, we will see. So we will get O double bond C. Here CH3 double bond O becomes single bond. O is making bond with MgBr. Okay, then we will take this for hydrolysis in the presence of acid. Hydrolysis in the presence of acid we will take. So this on hydrolysis, in the sense this bond is breaking, magnesium is having positive charge, so OH minus will give, oxygen is having negative charge, so that H plus will give. Okay, so what is the resultant? What is the result? We will see. The result is what means CH3, C double bond O, this OH. Therefore, we are getting acetic acid. We are getting acetic acid. This Mg becomes a MgBrOH. Mg becomes MgBrOH, that will be removed. Okay, therefore this Grignard reagent with carbon dioxide, that means this CH3 is combining with the CO2 to give acetic acid. Okay, suppose if we take C2H5 MgBr, if you take with the CO2, what you will get? This C2H5, that CO2 is COOH, that CO2 becomes COOH, like this we can say. Suppose if we take a C6H5, Grignard reagent is C6H5 Mgi, then you take this C6H5, then that carbon dioxide you write it as carboxylic acid. Okay, like this product we will get. So Grignard reagent with carbon dioxide, we are getting what, in the sense carboxylic acid. Then ester hydrolysis. Next we will go for a ester hydrolysis, gives carboxylic acid. We will take ester. It is ester. It undergoes hydrolysis. Hydrolysis in the sense in the presence of acid we have taken, in the presence of acid or in the presence of base, that we have to see. So hydrolysis in the presence of acid or hydrolysis in the presence of base. Okay, so hydrolysis takes place in which condition? In acid condition or in basic condition, that we have to see. Suppose we will take acid, then what is the mechanism, that we will see. Okay, acid we are taking, what is the mechanism, we will see. Now we are taking ester. Now we have taken ester, we are taking. Now we are giving acid H plus. So now this oxygen is attacking this H plus. So we are getting a CO. Then this OH or Air plus. Okay. Next water attacks. Next water is attacking. Water is attacking. This is attacking here. This going like this. Therefore R C O, here negative sign, here water will be there, oxygen will have positive charge, like this up to. Next what happens means this bond is migrating, this is leaving, here H plus is leaving, so H plus leaves, alcohol leaves. So what we are getting, in the sense carboxylic acid we are getting. Okay, so ester hydrolysis leads carboxylic acid. So how to prepare carboxylic acid, in the sense by oxidizing alcohol. Alcohol on oxidation gives carboxylic acid. Cyanide undergoes hydrolysis in the presence of acid or base. Acid or base giving carboxylic acid. Then we have discussed Grignard reagent with carbon dioxide. Here we have discussed Grignard reagent with carbon dioxide in the presence of dry ether gives carboxylic acid. Next one is ester undergoes hydrolysis in the presence of acid or base. Ester undergoes hydrolysis in the presence of acid or base gives carboxylic acid. Okay. Some more reactions about preparation of carboxylic acid. What reaction in the sense Koch reaction we are taking. Next one is Koch reaction. Next we are taking Koch reaction. Here we will take alkene, ethylene we will take. Alkene example ethylene. Then carbon monoxide, water. Carbon monoxide, water we have taken. We are taking acid H3PO4. Acid H3PO4, temperature is 675 Kelvin. Temperature we are keeping 675 Kelvin. So what we are getting, we will see this carbon monoxide carbon is converting into carboxylic acid. Therefore, we are getting a so and so. We are getting propanoic acid. We are getting what in the sense propanoic acid we are getting. Okay. So this carbon monoxide carbon is making bond with this carbon and becoming carboxylic acid. Okay. So how the mechanism? What is the mechanism involved here? That we'll see. Now this carbon monoxide will write this oxygen is having 6 electrons in its valence shell. Carbon is having 4 electrons in its valence shell. So here double bond is possible. Here dative bond is possible. Now we will write this is as resonance structure. We will write. Now here one lone pair is there. Here one lone pair is there. Dative bond we have written as normal covalent bond. For this, this is acceptor negative sign. This is a donor positive sign. Okay. So like this is. Now acid H plus. Acid gives H plus. Acid is giving H plus. Okay. So this H plus is attacking this carbon. So that what we will get in the sense HCO. Okay, HCO. This positive charge is there here. Positive charge is there. Now it goes for resonance. It goes for resonance. Resonance in the sense this pi bond is migrating. Therefore, we will get a carbon plus double bond O. O is having 2 lone pairs. Okay. This C plus, this plus is attacking this ethylenic double bonded carbon. Okay, ethylenic double bonded carbon, this C plus is attacking. So ethylenic double bonded carbon will take ethylenic double bonded carbon. This C plus is attacking now. C plus is attacking here. The pi bond is coming like this. Therefore, what happens means H, C, H, here positive charge, here CH, CH, here CHO. Okay, we are getting CHO. We got aldehyde. Then we got aldehyde here. Next, what happens means next step is here water comes for attack. Water is attacking. Water comes for attack here. Then means H3PO4 is there, and another one is here H minus attacks here. H minus attacks here. Here H minus attacks in this place. Therefore, it becomes CH3. This CH2 is there. Then this C double bond O. H3PO4 is an acid that oxidizes this aldehyde. Therefore, aldehyde becomes carboxylic acid. Aldehyde becomes carboxylic acid, we can say. This aldehyde becomes carboxylic acid because H3PO4 is oxidizing agent, therefore oxidizes aldehyde, therefore aldehyde becomes carboxylic acid. Okay, so now we will take a here a temperature provided 675 Kelvin. Okay, next reaction we'll see. Now we will take propene. So we will take this for Koch reaction. So here electrophile is C plus will attack, electrophile will attack this carbon, the double bonded carbon which is more substituted, that only electrophile will attack. Therefore, at this carbon only carboxylic acid will come. Okay. So At this carbon, carboxylic acid comes, CH2 becomes CH3. So this is the product we are getting. Okay, sir. So in this method, in this Koch reaction, we can prepare carboxylic acid. Next method we'll see. We'll take a chloroform. We are taking chloroform. Chloroform we'll take for hydrolysis in the presence of base. Hydrolysis in the presence of base. What happens means all the Cl will be replaced by, all the Cl minus will be replaced by hydroxide. All the Cl minus will be replaced by hydroxide, we can say. All the Cl minus is replaced by hydroxide. Therefore, the bond is shifting like this. Therefore, we will get a formic acid. We will get formic acid, water will be leaving. Water leaves. So we are getting chloroform on hydrolysis in the presence of base gives a formic acid. Okay. Next reaction we'll see. Now benzo trichloride. Now we will take benzo trichloride. Okay. We are taking benzo trichloride. Benzo trichloride we are taking. This undergoes hydrolysis in the presence of base. This undergoes hydrolysis in the presence of base. So all the Cl minus will be replaced by, all the Cl will be replaced by OH. All the Cl minus is replaced by OH minus. Here we use the word Cl minus, but if you add silver nitrate solution, can we get AgCl precipitate? That also we have to check. We will okay. So here Cl minus is replaced by OH minus, we said. Okay. Now this carbon is having more than one OH group, therefore water molecule is leaving. So we will get a benzoic acid. We are getting benzoic acid. So benzo trichloride on hydrolysis in the presence of base gives benzoic acid. Okay. Next method we will see. We'll take a sodium alkoxide. Sodium alkoxide will take. We are taking sodium alkoxide. To this we will add carbon monoxide and high pressure we are giving. We are giving high pressure. So what we are getting in the sense sodium salt of carboxylate we are getting. We are getting sodium salt of carboxylic acid. Sodium salt of carboxylic acid we are getting. It is treated with HCl. This on treating with HCl we are getting carboxylic acid. Okay, we are getting carboxylic acid. So alkoxide is treated with carbon monoxide at high pressure gives carboxylate. Carboxylate on treating with acid gives carboxylic acid. Okay, like this we are preparing carboxylic acid. Then manufacture of acetic acid, in that one method we'll see. We are taking acetaldehyde. We are taking acetaldehyde. It is treated with atmospheric air. It is treated with atmospheric air in the presence of cobalt acetate catalyst. In the presence of cobalt acetate catalyst. Cobalt acetate catalyst. At what temperature? In the sense 353 Kelvin. At 353 Kelvin, this acetaldehyde is becoming what? In the sense acetic acid. Acetaldehyde is becoming acetic acid. Pure acetic acid we are getting. This aldehyde undergoes oxidation here. This aldehyde undergoes oxidation to give what? In the sense carboxylic acid. This aldehyde undergoes oxidation to give carboxylic acid. Here we have taken catalyst cobalt acetate catalyst. Cobalt acetate catalyst. Okay. Next we will take methyl alcohol. We will take methyl alcohol. This methyl alcohol we will treat with carbon monoxide. What is the catalyst we are taking? Means rhodium catalyst we will take. We will take rhodium catalyst. Now, this methyl alcohol with carbon monoxide, what we are getting in the sense acetic acid we are getting. We are getting acetic acid. This methyl alcohol on treating with carbon monoxide in the presence of rhodium catalyst. In the presence of rhodium catalyst, we are getting what? In the sense acetic acid. So methyl alcohol on treating with carbon monoxide in the presence of rhodium catalyst, what we are getting means acetic acid we are getting. This is also pure form of acetic acid we are getting here. Okay. So remember that methyl alcohol with carbon monoxide in the presence of rhodium catalyst, we are getting a what is the product? In the sense acetic acid, pure acetic acid we are getting. Next reaction we will take now. Now we will take a, in the aromatic compound we will take, in the aromatic compound alkyl side chain we will take. This alkyl side chain present in where, in the sense in phenyl ring. Okay, in the phenyl ring, this alkyl side chain is there. The carbon attached to phenyl ring must have at least one nitrogen. Okay, this alkyl side chain where it is there means in the phenyl ring it is there. The carbon of alkyl side chain attached to the phenyl ring must have at least one hydrogen. Then this on oxidation in the presence of oxidizing agent, what in the sense acidified permanganate. Acidified permanganate. Otherwise, alkaline permanganate. Alkaline permanganate. Otherwise, chromic acid, H2CrO4, chromic acid. Otherwise, concentrated nitric acid. Concentrated nitric acid. What happens means the alkyl side chain becomes carboxylic acid. Alkyl side chain becomes carboxylic acid irrespective of size of alkyl side chain. Whatever the size of alkyl side chain, that will become carboxylic acid. Okay, so suppose given is toluene. Given is toluene. Now this on oxidation, what you will get means you will get benzoic acid. Okay, CH3 alkyl side chain becomes carboxylic acid. Suppose given is a N-propyl benzene. Suppose given is what in the sense N-propyl benzene. What you will get in the sense you will get benzoic acid. That N-propyl group becomes carboxylic acid. So whatever the size of a side chain, that will become carboxylic acid. Okay. Suppose given is like this xylene. Suppose para-xylene is given, or meta-xylene is given, or ortho-xylene is given. Now it will become what means each alkyl group will become carboxylic acid. Each alkyl group will become carboxylic acid. Therefore, you will get like this two carboxylic groups will be there. If you take ortho, you will get ortho isomer. Meta means meta isomer. Para means para isomer. Like this you will get. Okay. So like this only we are preparing carboxylic acids. Okay. So carboxylic acids preparations we have seen. Next we will see the properties. Benzoic acid is insoluble in cold water but soluble in hot water. Benzoic acid is insoluble in cold water but soluble in hot water. Then boiling points we will see. Boiling point of carboxylic acids we will see. Boiling point of carboxylic acids in the sense, now we will take acetic acid, its boiling point is 390 Kelvin. Then we will take N-propyl alcohol. For N-propyl alcohol, what is the boiling point in the sense 370 Kelvin. Then we will take butane. N-butane will take, we are taking N-butane. For N-butane boiling point is 309 Kelvin. Now molecular mass is nearly same for these three. Now N-butane molecular mass is very less because intermolecular force is van der Waals force, that is instantaneous dipole. Induced instantaneous dipole is possible here. In alcohol, boiling point is more when compared to alkane. Why? Because here hydrogen bonding is possible from the OH group. In acetic acid, boiling point is more than this alcohol because acetic acid can form stronger hydrogen bonding when compared to alcohol. Acetic acid forms stronger hydrogen bonding when compared to alcohol. Why acetic acid forms stronger hydrogen bonding in the sense here electron withdrawing group is there. CO group is electron withdrawing group. Due to this electron withdrawing group, this hydrogen is having more magnitude of positive charge when compared to this hydrogen. Alcohol hydrogen is having less magnitude of positive charge. Carboxylic hydrogen is having more magnitude of positive charge because electron withdrawing group CO. Therefore, it forms stronger hydrogen bonding, whereas it forms weaker hydrogen bonding. Therefore, carboxylic acid is having more boiling point when compared to alcohol. Next, we will see about a melting point. We will see melting point of carboxylic acids. We will see how the melting point of carboxylic acids will be there. How the melting point of carboxylic acids will be there. That point we will see. We will take an example. Now we will take a propanoic acid. Propanoic acid formula CH3 CH2 COOH. For this melting point is 251 Kelvin. Melting point is 251 Kelvin. Then we will take a butanoic acid. Butanoic acid we will take. For butanoic acid, melting point is how much in the sense 267 Kelvin. Next we will take pentanoic acid. Pentanoic acid we will take. For this melting point is 237 Kelvin. Okay. So how the melting points are there? You see that melting points even number of carbons, in the sense melting point will be higher. Odd number of carbons, in the sense melting point will be lower. Like this is there. Now see that butanoic acid is containing even number of carbons, melting point is high. Then this side and that side, left side and right side, if you see odd number of carbons, it is having three carbons, melting point is lesser than this. It is having odd number of carbons, its melting point is lesser than this. So odd number of carbons and even number of carbons. Even number of carbons, in the sense that melting point is higher than left side and right side of odd number carbons. Okay, so melting point is like this is there. Then aromatic acids and aliphatic acids will see. Aromatic acids will have higher melting and boiling points. Aliphatic acids will have lesser melting and boiling points. Then we will see the acidic strength. Now we will take carboxylic acid and alcohol. Alcohol will take. What about acidic strength for these two? That we will see. Carboxylic acid gives H plus and becomes carboxylate anion. Carboxylate anion. Carboxylate anion. Alcohol gives H plus and gives alkoxide ion and gives alkoxide. Now, this carboxylate anion goes for resonance. This carboxylate anion goes for resonance. It goes for resonance. Goes for resonance, we can say. Okay, for carboxylate anion, resonance is possible. Due to resonance, this stability is more when compared to this. Here stability is less, and also this R shows plus I effect. Due to plus I effect, this oxygen is having high electron density when compared to this oxygen. This oxygen electron density is low. This oxygen electron density is high. Electron density is high. Why? Because this R group shows plus I effect, positive inductive effect. Since it shows plus I effect, this O minus is having high electron density. Because of like this resonance, this O minus is having less electron density. Therefore, out of these two, which is having higher stability, in the sense this has higher stability when compared to this. Therefore, here forward takes place to more extent. Forward takes place to more extent. Here forward takes place to less extent. Therefore, this acidic strength is more. This acidic strength is more. This acidic strength is less. Okay. So that carboxylic acid is having higher acidic strength, higher acidic nature than alcohol. So carboxylic acid acidic nature is more when compared to alcohol. Sir, carboxylic acid and phenol, that we will see. Now we will take phenol. We will take. So phenol we will take. Carboxylic acid and phenol, which is having higher acidic nature, we will see. Here bond is shifting like this. So we are getting phenoxide. We got phenoxide and H plus. This phenoxide undergoes resonance. This phenoxide undergoes resonance like this. So phenoxide undergoes resonance. Therefore, we will get a here negative charge like this. Phenoxide undergoes resonance. Now carboxylic acid and phenol. Carboxylic acid and phenol. Which is more acidic? Okay, now we have taken carboxylic acid and phenol. Which is more acidic? We want to discuss. Carboxylic acid gives H plus and carboxylate anion undergoes resonance. Phenol gives H plus and becomes phenoxide. Phenoxide undergoes resonance. Now, these two resonance structures are equivalent. The carboxylate anion, this carboxylate resonance structures are equivalent. This phenoxide resonance structures are non-equivalent. Why non-equivalent? Here negative charge is possessed by high electronegative oxygen. Here negative charge possessed by less electronegative carbon. Therefore, these two resonance structures are non-equivalent. These two resonance structures are non-equivalent. but these two resonance structures are equivalent. Okay, these two resonance structures are equivalent, we can say. So these two resonance structures are equivalent, these two resonance structures are non-equivalent. These two resonance structures are non-equivalent, we can say. Okay, so these two resonance structures are non-equivalent, whereas these two resonance structures are equivalent in the sense, for this stability is more, for this stability is less. That's what it means. These two resonance structures are equivalent, therefore this stability is more, for this stability is less. Therefore, this acidic nature is more, this acidic nature is less. So phenol is having less acidic, carboxylic acid is having more acidic. Okay. So carboxylic acid, acidic nature is more. Carboxylic acid, acidic nature is more. This phenol is having less acidic. Okay. So one point already we said, carboxylic acid is more acidic than alcohol. Now we are saying carboxylic acid is more acidic than phenol. Okay. Phenol and alcohol, if you see, phenol is having more acidic than alcohol, because in phenol, phenoxide is going for resonance, alkoxide is not going for resonance. Okay. Next, we'll see carboxylic acid and peroxy acid. Carboxylic acid we'll see and peroxy acid we'll see. Now it is a peroxy acid. It is peroxy acid, per acid we can say. It is a acid, therefore it gives H plus, therefore we'll get a anion, we'll get anion. This anion cannot go for resonance. This anion cannot go for resonance. But carboxylic acid, but this carboxylic acid can go for resonance, can go for resonance. Carboxylic acid can go for resonance, but this peroxy acid cannot go for resonance. Therefore, which is having more stability? Carboxylic acid is having more stability when compared to this. Therefore, which is having a more acidic nature? Carboxylic acid is having more acidic nature. Okay, carboxylic acid is having more acidic nature when compared to this peroxy acid. So which is having more acidic nature means carboxylic acid is having more acidic nature when compared to peroxy acid. Sir, next we will take CH3, CH2, CH, Cl, COOH will take. Then we will take CH3, CH, Cl, CH2, COOH will take. Which is having higher acidic nature? Which carboxylic acid is having higher acidic strength? That we will see. Which carboxylic acid is having higher acidic strength? That point we will see. Okay. So now here we can say carboxylic acid like this. Here we can say carboxylic acid like this. Okay. Which carboxylic acid is having higher acidic strength? Cl shows minus I effect. So this bond migrates like this. This bond migrating, this bond migrating, this bond migrating. So it gives H plus. So this compound gives H plus, therefore this compound is acid. Cl shows minus I effect, negative inductive effect. This bond migrating towards Cl, this bond migrating this side, this bond migrating towards left, this bond migrating towards left, this bond also migrating towards left. It is giving H plus. Therefore it is acid. Both are acid. So inductive effect is weak effect. Why? Because sigma bond is involving in it. Sorry. Inductive effect strength depends on distance. If distance is less, inductive effect strength will be high. Okay, here distance is less. Okay, here distance is less. Here distance is more. Here distance is more, but because carboxylic acid and Cl distance is more. Carboxylic acid and Cl distance is less. So effect of inductive effect is high, effect of inductive effect is low. Therefore, here electron cloud is shifting to larger extent, electron cloud is shifting to lesser extent. Therefore, it gives H plus easily when compared to this. Therefore, it is having higher acidic strength when compared to this. So acidic strength is like this. Okay. So if minus I group, is closer, then inductive effect will be, the inductive effect strength will be more. Okay. So now we will take a, what in the sense, gamma chlorocarboxylic acid will take. Gamma chlorocarboxylic acid. Gamma chlorocarboxylic acid. This Cl shows minus effect. Here this Cl shows minus effect. How acidic strength will be there here? How acidic strength will be there here? That means even less than this. This will have more. This will have more acidic strength when compared to this. This will have more acidic strength when compared to this, we can say, because minus I group is somewhat far away. Now we will take a carboxylic acid having no Cl. Like this we will take. Carboxylic acid is not having Cl. Here Cl is there, here Cl is not there. Cl shows minus I effect. Here no minus I group. Therefore, this is having more acidic nature. If electron withdrawing group is there, then carboxylic acid can donate H plus easily. If the carboxylic acid is having electron withdrawing group, then it will donate H plus easily. If carboxylic acid is having electron donating group, then it will not donate H plus easily. So carboxylic acid will have more acidic strength if it is having electron withdrawing group. Okay. So electron withdrawing group favors carboxylic acid to have more acidic strength. Electron donating group is not favoring carboxylic acid to have more acidic strength. Sir. Next we will take a pentanoic acid we will take. So the pentanoic acid we are taking. Pentanoic acid we have taken. Now we will write one of the carbon as a branch. We will write one of the carbon, we will write it as a branch. So how the acidic strength will be there, we will see. Now here alkyl group shows plus I effect. So here one alkyl group is there, it shows plus I effect. Here if you see, this alkyl group shows plus I effect. This alkyl group shows plus I effect. So plus I effect, here plus I effect strength will be more, here plus I effect strength will be less. Molecular formula is same only, but this length is more, this length is less. Alkyl group is closer. This CH3 group is closer here, closer to carboxylic acid. This CH3 group is far away from carboxylic acid. This carbon is far away from this carboxylic acid, but this carbon is closer to carboxylic acid here. Therefore, plus I effect is more, plus I effect is less. Plus I effect means a positive electron donating. Therefore, it can donate H plus easily, whereas it is not donating H plus easily. Therefore, this acidic nature is what we can say means more, we can say. So we can say this acidic nature is more when compared to this. Okay. So this acidic nature is more. If the CH3 group goes still more closer to carboxylic acid, what will happen to acidic strength? You think it. If alkyl group goes closer to carboxylic acid, this alkyl group goes still closer to carboxylic acid like this. Then what happens? Plus I effect still more increases. Plus I effect still more increases means acidic nature again still decreases. Therefore, this acidic nature is even less than this. Okay. So like this acidic strength is there. Now we will take another compound CH2 double bond CH, CH2 COH. Like this carboxylic acid we will take. Next we will take carboxylic acid like this CH3 CH2 COH will take. Now we have taken two carboxylic acids. How the acidic strength will be there in the sense? It is having more acidic strength when compared to this. Why? Why it is having more acidic strength when compared to this? Because this carbon is sp3 carbon. This carbon is sp2 carbon. sp2 carbon means electronegativity is more. sp3 carbon means electronegativity is less. Why sp2 carbon is having higher electronegativity? Because percentage of S character is more here, that is 33.33%. Here percentage of S character is less here, that is how much in the sense 25%. Percentage of S character is less, that's why electronegativity is less. Electronegativity is less in the sense it is having less acidic strength. It is not donating H plus easily. It is donating H plus easily, we can say. Okay. Next compound we will take. Next compound what we are taking in the sense CH triple bond C, CH2, COOH. Carboxylic acid we have taken. Next carboxylic acid is CH2 double bond CH, CH2, COH. Carboxylic acid we have taken like this. How the acidic strength is there means this is having more when compared to this. Why it is having more? Because this carbon is a sp carbon. Sp carbon means percentage of S character is 50%. This carbon is sp2 carbon, percentage of S character is 33.3%. So percentage of S character is more here. Percentage of S character is more, therefore electronegativity is more. Percentage of S character is less, therefore electronegativity is less. So that it is having more acidic when compared to this, we can say. Okay, sir. Next we will take another compound CH3CO, CH2COOH. This carboxylic acid. Next carboxylic acid we will take CH3, CH2, COH. Acidic strength, if you see like this is there. Why acidic strength like this present? Because it is electron withdrawing group. Electron withdrawing group it is. Because this pi bond can migrate, therefore this bond is shifting like this. Electron withdrawing group present means carboxylic acid will donate H plus easily. That means acidic nature will be more here, we can say. Next we will take a cyanide. We are taking cyanide. CH2COH. This carboxylic acid we have taken. Another carboxylic acid we will take a ketone. Now CH2COH. Okay, we have taken here cyanide, we have taken here ketone. Now, which is how the acidic strength will be there. How the acidic strength is there? Acidic strength is like this. It is having more acidic strength when compared to this. Why? It is electron withdrawing group. It is electron withdrawing group. It is sp carbon. It is sp2 carbon. Therefore, it is having more acidic when compared to this. Okay. So next we will see. Now, malic acid and fumaric acid we will take. Both are geometrical isomers. Now, how the acidic strength is there? They are dicarboxylic acids. Dicarboxylic acids in the sense Ka1, Ka2 possible. Ka1, Ka2 possible. Sir, how Ka1 is there? Ka1 in the sense acid dissociation constant. Ka1, how it is there in the sense malic acid is having high. That means this acidic strength is more when compared to this. Sir. Ka2 also is there because dibasic acid. Therefore, Ka2 also is there. How Ka2 is there means it is more. What is the reason? Why it is having more value? Ka2 is more for this. What is the reason? We'll see. So malic acid will take. Malic acid formula is like this. Malic acid formula is like this. Malic acid formula is like this. Okay. Now it is donating H plus. After donating H plus, it becomes what we'll see. After donating H plus, it becomes like this. Here, hydrogen bonding is possible. Between this O minus and H, hydrogen bonding is possible for malic acid. Sir, fumaric acid we will take. What about fumaric acid? That we'll see. Fumaric acid in the sense fumaric acid we are taking like this. It is giving H plus. It is giving H plus. Therefore, we are getting a like this. Fumarate anion. Here no hydrogen bonding. No hydrogen bonding means stability is less. Here hydrogen bonding stability is more, therefore this acidic strength is more. This acidic strength is more, but this acidic strength is less. This acidic strength is less. Okay. So fumaric acid is having less acidic. Malic acid is having more acidic. Therefore, Ka1 is more for malic acid. Ka1 is less for fumaric acid. So, next we'll see it is a dibasic acid. Therefore, it will give another H plus.